are you and what are we doing here?
Yeah, so my name's Owen. I'm the co-founder and CEO of MastChain.
Hi, I'm Daneiel Brazzolotto. I'm the CTO of MastChain.
And we are here at the Web3 Summit in Berlin for 2026.
What did you do before you started this company?
Yeah, I used to work in the maritime industry. So I worked with emissions compliance for a big engine manufacturer who made very big ships engines.
And in my case, I've been in tech all my life, specifically in software development. I've been doing a bunch of other things before here in different industries, from the dentistry industry to photography industry. But my heart has always been on tech development, specifically software development.
What is MastChain and what problem does it solve?
So MastChain is a DePIN for ship tracking data. So what we do is we're a decentralized physical infrastructure network, and we have a community of receivers out there collecting ship tracking data all across the world. And what it's solving is it's decentralizing the data collection of the shipping industry.
What is the mastnode in simple terms?
So a mastnode is a plug-and-play station that allows you to start collecting ship tracking data and start getting rewarded in Mast token.
Who is Onakoi and how did this partnership come about?
So Onakoi is a RTK corrections network. So they collect GNSS, which is like GPS data from satellites, and then they do something what they call corrections to this. The mastnode has a GNSS chip that allows us to feed data to the Onakoi network. So that means that you can actually dual mine tokens on the mastnode itself. So you collect AIS data, and you can also collect the satellite GNSS data that is useful for Onakoi. So we worked in partnership with them and realized that our one device, our mastnode, could then supply data into their system.
What does dual mining actually mean for somebody running a mastnode?
So dual mining means that there's now 2 token revenue streams for one device. So they're taking one device, the mastnode, which was traditionally for just the MastChain network, which means you get just Mast tokens. But with this partnership with Onakoi, a mastnode owner can now get 2 token revenue streams. So from Mast and also from the Onakoi Ono token. And today the Ono token is on mainnet. So that means you can start actually getting an ROI on the station today.
Why does combining AIS and GNSS data on one device make sense?
Because AIS data also need a GNSS chip for the understanding the position of the receiving station. This is useful for terrestrial receiver, but even more useful if the mastnode is on board the vessel and keeps moving. And we also need it for assigning correct timestamp to the data we receive. Now, since the chip is already there, it was a bit of a no-brainer to also enable the second mining option, because I think it's an elegant use of the hardware that is already been deployed.
Why does this partnership matter for DePIN as a whole?
So I think in order to scale DePIN, projects should, if they are complementary to each other, they should be working together. So in order for DePIN to really scale beyond what current centralized providers are doing and centralized Web2 companies are doing, if we want to really get adoption in Web3, projects should be working together if they are complementary.
What problem did you see that made you want to build this?
So I saw quite a centralization in this shipping data space. There was one company who went in and bought up and consolidated the entire sort of network of AIS receivers. And they then started to act like a monopoly and limit access, increase prices. And this priced a lot of people out of the market for this data.
How did the idea first come to you?
Yeah, I think it very much came from me because I was buying data and using this AIS ship tracking data. And I had to go to this one company to purchase it. And the cost of the data was phenomenal. And in fact, it killed my project dead with what I wanted to do with the data. And I just felt there was a better way to source data and also fairly reward contributors who go and set up infrastructure and collect collect data for us.
If you could describe MastChain in one sentence, how would you describe it?
Shipping data verified.
What is a mastnode and what does it do?
A mastnode is essentially a standardized station. In order to have this project going, and the way that the data collection happens for vessel is that the vessel broadcasts a radio frequency, and that has a limited range. So you need to have this receiving station all over the world that capture the data and then process it. Now, if you basically build your own station, there is a lot of variation in performance, and support becomes difficult, and a lot of the operators have trouble to actually get these nodes operational, especially with good quality. So a mass node is essentially a way to say, okay, it's a standardized station that collects data in a standard way, and we know the performance really well. It's easy to maintain, easy to operate.
Could you explain the GNSS chip and the timestamping?
Right. Yeah. So one of the problems of capturing this data from vessel is that the protocol that the vessel broadcasts, they don't have any real timestamp attached to it, because the protocol has been designed for collision avoidance, not for data analytics. So someone shouting. So basically the workaround for this is that, well, we need to assign the timestamp. We need to know when events happens. We need to know that, yes, a message might say that the vessel is out here, but we need to know when that event. So the way to solve this in a consistent way is to have the timestamp coming from a GNSS chip. So that's why the mass node also contains a really good quality GNSS chip, and then because of that, we know where the station is, and we also know exactly when the events happen.
Okay. Who is the customer?
So there's over 25,000 data buyers across 35 different industries. AIS data and ship tracking data is the foundation of a lot of analytics products. And these might be banks and financial institutions. They could also be governments. They could also be shipping companies and fleet managers who need to know exactly where their ships are at any given time. And even down to organizations like Coast Guards who need to understand where ships are within a given area, even to port operators. And as I say, there's over 25,000 different data buyers that we've found, and they spend anywhere from 5,000 up to and above $1 million per year on this data set. So it's incredibly valuable data.
Could you explain to me what is DeepIn and why is it relevant today?
DeepIn stands for Decentralized Physical Infrastructure Networks, and this is a way of crowdsourcing basically physical infrastructure to support various networks. And these could be telecommunications networks, they could be file storage, it could be GPUs. But in our case, we are crowdsourcing the collection of shipping data. So we have a community all around the world of people who go out, set up hardware, they maintain it, collect the data, and then in return, we do a revenue share with them. And I think DeepIn is more relevant today than at any other point. So there's a lot of issues with storage centers and cloud storage centers, and there's not enough room and infrastructure in traditional centralized methods. So utilizing these types of community outreach and community-based networks to grow the infrastructure, I think it's more relevant today than it has ever been.
What is AIS data and why does it need to be on blockchain?
Yeah, so AIS data is a short burst of information that commercial vessels broadcast by law, actually, all over the world. And the original purpose of AIS data is collision avoidance. If you are in bad visibility and you have a big, slow, and difficult to maneuver vessel, you need to know that you're not in a collision course. So by broadcasting what vessel it is, how big it is, where you're going, how fast, and which direction, then the other vessel around can detect this information and react accordingly. Now, the same data, this broadcast has a range of between 50 and 150 kilometers, more or less, depending on weather and a few other factors. And this is also valuable for analytics. There is a lot of value in understanding where vessels are and what they're doing. but because it's localized, you need to have a local station that picks up this data and then forward it so that you can collect overall this data from around the world and then have a picture of how's global shipping moving.
What makes a deep-in project succeed versus fail?
I think community. It's the community is the foundation of all deep-in projects. So you need to have a very strong community of people around who are willing to set up this infrastructure. And I think deep-in projects, to be successful, have to have a community-first mindset. And you need to ensure that the community they feel heard and they feel valued. And then the revenue that a business makes with the data that a community collects needs to be fairly shared with them. So I think going back to what makes a successful deep-in project, community.
These are questions about the business. Where are you right now in terms of growth?
Yeah, so we're about to enter quite an exciting growth phase. We are basically taking this next 12 months to grow the network as best as we can. And we're doing this through partnerships, be it with other deep-in projects or getting out there and just speaking with as many potential operators within the deep-in space as possible.
How does the business make money?
Yeah, so what we do is we're collecting this data, we aggregate the data. We then work with traditional institutions and enterprises, and we package and sell this data to them. We take part of the revenue from our data sales and we feed it back into the community via token buyback and burns.
Who are we competing with?
Yeah, so we are competing with traditional centralized companies, sort of in the Web2 space. These older, more established companies who have very much centralized ideas and capitalistic ideas that we are trying to chip away at their market share, utilizing Web3 and utilizing deep-in and community to outscale them.
What's next for MastChain?
So what is next is very much a period of growth. So we intend to grow the network as much as we can. We intend to do this through the Mast node.
The Mast node is going to be generally available very soon, and is going to be the piece of tech that's going to unlock this growth. So from where we are today, we expect it to grow like 5 to 10 times over the next 12 months.
And we're expecting this growth to happen just by reducing friction of onboarding into the network. So by having a truly plug and play piece of hardware that just makes it simple to deploy, and also for people to own and host stations all across the world. We see that the key to real growth is with this ease of access into the network.
What is wrong with how AI's data is collected and distributed today?
It's expensive, essentially. It's expensive, and it generates like not all the coastal area covered by terrestrial receivers, which means that there is an over-reliance on satellite data. And the problem with satellite data is that, one, it's often delayed by 20 minutes, 45 minutes, something like that. And number two, is way more expensive than terrestrial receivers. So by expanding the terrestrial receiver network that is generally available out there, we have the option to kind of bring down the cost for the people that use this data and have a lot more like real-time feedback on the global vessel positions, basically.
How easy is it to fake or manipulate signals?
Unfortunately, very easy. We have seen a lot of this in the last 6 months, especially in the Gulf region, but it's because there are different number of attack vectors that you can use to manipulate or completely block this data from happening. Because this is not designed as a data protocol. This has been designed as a collision avoidance protocol. There is no encryption. It relies on GPS position. So by manipulating GPS position, you can manipulate the position reported by vessels. And this is a big problem. It's a big problem because the moment you use this data to take decision, financial decision, or otherwise, even insurance-based assessments and so on, if you're based this on the wrong data or the data that is false, then obviously you're going to have with suboptimal results. So as part of our network, we also have quite a complex mechanism to validate the data that we receive, and we assign kind of the likelihood that that data is actually truthful. And this is an incredibly valuable piece in the whole chain, because it starts to give transparency about what kind of data you can trust and what data you cannot trust.
Why has nobody solved this before?
It's difficult. It's difficult, and especially because the data is collected locally, it takes a lot of energy and effort to build this community, especially if you go for a centralized route. If you are a centralized company and you try to, distribute around the world in every country, in every jurisdiction, you need to have station deployed. This is a lot of work, a lot of paperwork as well, to be clear from the legal point of view. So this is actually a perfect example where a community style kind of deep in project has a lot of advantages over a centralized company.
Walk me through what happens from the moment a ship broadcasts a signal to the moment where it's delivered to a customer.
Right. So the moment, vessels that are moving, they broadcast, they ping out basically their position, speed, and a few other information every 10 seconds. That message travels to the closest stations, within the range of the radio frequency. The moment the station picks it up, it collects that position together with other position in the area, signs the data, and then forward it on. And then that signature provides the proof that that message is being picked up by that particular station, and that's really important for traceability, because in this way we can assess both the likelihood that the vessel is broadcasting the truthful position and state, but also the probability that that station is also behaving correctly and not manipulating the data by itself. And then after that, the data gets ingested, processed, analyzed, and then forwarded to the clients.
What is the role of the chip inside the mastnode?
Inside the mastnode, there are different chips. There is an AIS decoder, which is used to convert the radio frequency into their digital content. There is a GNSS chip, which is used to determine the precise position of the node, the receiving station, as well as assigning correct timestamps to the different events that the node picks up. But there is also a secure chip, and the secure chip is quite important in our infrastructure because it's what allows the data to be signed and have a cryptographically secure trace of where the data is coming from.
How does the network know if a signal is genuine or spoofed?
It does it in different ways, but the core concept is that there is analysis that's being run on the data being ingested. And this analysis is essentially based on the fact that we know exactly for each individual message which station picks it up. And because of that, and because we can trust that, because of the signature of that data, we can run analysis and say, okay, let's give you an example, like a certain vessel is being picked up by a station in Muscat, but if that vessel claims to be on the other side of Africa, clearly there is something wrong because physically that's not possible. So that's one example where by knowing which station picks up what messages, we can run analysis based on the vessel behavior and the station position and determine the likelihood of that data to be correct.
What does anchoring data on blockchain add technically?
The benefit of using a blockchain for this problem is that it's very easy to get data immutability via the blockchain, and this is a very elegant solution, very technical, elegant solution for determining that once data is received, it cannot be further manipulated. We know exactly, via cryptographic signature, what station generated data, and the blockchain becomes the truth layer that we can base other analysis on.
How do you handle situations where two mastnodes receive the same signal?
Oh, we want that actually. It's having only one mastnode receiving data from a specific vessel. It's a good starting point. We have a good reliability there, but I think the real objective is to have at least two mastnodes receiving the same data, and this is because it provides redundancy against power cuts and network issue, but it also provides a second layer of security because if two independent nodes detect the same data and independently validate that the vessel is there, that's another increased confidence that the vessel is actually where it claims to be.
What does the network need to look like before the data is commercially useful?
Yeah, so we need to ensure that we have nodes distributed in high-value areas around the world. And high-value areas to us look like ports. They look like choke points. So areas that you have a lot of shipping traffic moving in very specific places. So ideally, we're looking to distribute or have our community distributing nodes in and around these areas. So what we do to incentivize this is we place bonuses, so token reward bonuses in various parts of the map where we might have commercial data buyers who are specifically interested in a geographic location. We try to tailor the rewards to that. So if you're an operator and you see there's a 2x bonus in a specific area, that's us saying, hey, we need a node here, and we would highly value it if you could go and deploy something.
What is the hardest engineering problem you're still working on?
Scale. So one of the characteristic of this project is that we're working with a lot of data. If you imagine the immense volume of commercial vessels around the world today, and each of them broadcast their position every 10 seconds, you end up with a humongous amount of data. And the way that this data interacts both with different stations and with the different components of the system, but especially with the blockchain and the kind of distributed part of the system, that's the hardest problem for sure, because we are talking about an immense stream of data that we want to treat real time. We want to validate each individual data package, but doing it at volume and doing it cost effectively.
And the last question is the closing question. How can somebody get involved by running a node?
Yeah, so they can come and find us in our Discord community. Links are on our website of MastChain.io. You can also find us on X, which is MastChain_DPIN. And yeah, we're usually posting links there and we're posting content there continually.